This lesson is 1.6 scientific notation. We're on page 52, so if you need to pause the video, go ahead and do so now and get to that page. Okay, so scientific notation is a way that we can write numbers that are really, really big or really, really small. So it has to be written as a product of a factor, a product, so times a number, and then a power of 10. This power can be positive or negative, and this number has to be basically between 1 and 10. It could be equal to 1 or more, but it has to be less than 10, and that's what this says right here. So it has to be a number basically between 1 and 10 times a power of 10, and again, this can be a positive or a negative exponent. Okay, so let's take a look at these first examples, writing numbers in standard form. So standard form is just a regular number. So basically, right now these are in scientific notation, and we're going to write them as a regular number. Oops. Okay, so we're going to take the number we're given, 5.34, and we're going to look at the exponent on the base of 10. So this is a positive 4. So positive 4 means you're going to take this decimal and move it 4 places to the right. 1, 2, 3, 4, and it ends up right here. So you're going to add zeros where you need to in the blank spots, and then our new number is 53,400. So we took this number in scientific notation and we wrote it in standard form just by moving the decimal 4 places to the right. So if you take a look at number 2, we're going to do the same thing. This time we're using 3.27, and also this time you have a negative exponent. So because it's negative 3, this time we're going to move the decimal 3 to the left. Think negative on the number line. So we're going to go 1, 2, 3. This is where our decimal ends up. We're going to put zeros in the spots we created. And then that is our answer, 0.00327. Notice when you have a positive exponent, your number is going to be a whole number, 1 or more. When you have a negative exponent, your answer is going to be a decimal like this. Okay, let's try just a couple more. Let's try A. You try this one with me. So we're going to write 7.42, and because it's positive 5, we're going to move the decimal 1, 2, 3, 4, 5 places to the right. Think right on the number line is positive. And then we fill these in, so 742,000. And let's try this one. We're going to write 6.1. Our exponent is negative 2. This time I'm going to move left 2 places. 1, 2, and it ends up right there. So 0.061 would be our answer for that. Okay, now let's take a look at numbers that are written in standard form. Let's go the other way around now. They're written in standard form, and we want to write them in scientific notation. So we want to take this number, 3,725,000, and write it in scientific notation. So what we're going to do is we're going to take the decimal. The decimal's at the end of the number right now. And we're going to count how many times it takes for us to move it to make this number between 1 and 10. Remember, to write in scientific notation, the first number has to be 1 or more but less than 10. So let's count. 1, 2, 3, 4, 5, 6. If I stop my decimal right there, my number will be 3.725. And now I can drop the zeros off, I don't need those, and now this number is between 1 and 10. So I'm going to write times 10 to the, okay, let me count one more time. We moved it 1, 2, 3, 4, 5, 6. So our exponent is 10 to the 6th. And it's a positive exponent because we started off with a whole number more than 1. So now let's take a look at this one. This number is written in standard form. It's a regular number. Now we're going to write it in scientific notation. So let me rewrite this, and now we're going to move the decimal and make this number between 1 and 10. Right now it's less than 1. So let's count. 1, 2, 3, 4. If I stop my decimal right there, my number is 3.16. I don't need these zeros in front anymore. And 3.16 is between 1 and 10. So I want to leave it right there. If I leave it here, it's still going to be less than 1. If I move it here, it'll be 31.6. So I have to stop it exactly right there. and then we write times 10, and we moved it 1, 2, 3, 4. This time our exponent will be negative because we started off with a number between 0 and 1. So less than 1. We started off with a decimal. That's why our exponent is negative. Okay, let's just try a couple more of these. So we're at the top of page 53. So do these with me. We'll do a couple. So let's write 14,140,000. And now we're going to move the decimal to make this number between 1 and 10. So here's my decimal right here. Let's count. 1, 2, 3, 4, 5, 6, 7. Let's stop it right there. So if I stop it right there, 1.414, I don't need the zeros at the end, and this number's between 1 and 10. So then I'm going to write times 10 to the 7th because I moved the decimal 7 times. And it's a positive 7 because I started off with a number more than 1. Okay, and then let's take a look at one more. Let's do problem E. Do it with me on your page. 0.00876. So now we have a number that's less than 1, so our exponent needs to be negative in the end. Okay, so I'm going to move this decimal to make this number between 1 and 10. It could be 1, but it's not going to be. So if I move it 1, 2, 3, 3 times, and I stop it right there, and I drop the zeros, now my new number is 8.76 times 10 to the 1, 2, 3, negative 3. I moved it 3 times, so my exponent is 3, and it needs to be negative because I started off with a number less than 1, between 0 and 1. So this is written in scientific notation. Okay, we will practice more tomorrow.